He's the myth. He's the legend. He's the scientist with all the answers to all the questions. It's time for another episode of Alex's Science Corner.
Thank you.
What's going on in the wide, wide world of science, my friend?
Well, first up is a story about the Hayabusa 2 probe. Hayabusa is a Japanese probe that was sent to orbit an asteroid. And the Hayabusa is Japanese for Falcon. The fun part about this is this probe has been orbiting this asteroid for several weeks now. And it also launched 2 rovers onto the asteroid. And I know I had shown a picture of these rovers, and I talked about this earlier with you guys, because the rovers don't have any wheels. What they do is they bounce along the surface of the asteroid.
I remember you talking about these guys, yeah.
Yeah, so what is bringing the probe back into the news cycle again is that it was collecting a physical sample of the asteroid. And so what it had to do is it had to fly down, contact the asteroid, collect the sample, and come back up. Obviously, because this asteroid is spinning around, it had to do a lot of maneuvering to do that. And as it was coming down, they had to lose contact because for the probe to be able to make contact with the asteroid safely, they would not be able to keep the antenna pointed to Earth. So the whole process was automated or autonomous. So what was happening was as the probe got closer and closer, it would lose contact with Earth. When it finally made contact, it'd fire a bullet into the surface, and the debris that shot up from where the bullet impacted would be collected in this collection cone. And the whole process should only take a couple of seconds, but it's a case of touching the surface and then pulling away after the debris is collected. What they're expecting to do was find a flat surface and bring the probe down there to keep it safe. Unfortunately, Hayabusa, or the asteroid, is so debris strewn that it's all boulders. And so
no flat surface.
No flat surface that they could find. So when the probe was coming down, if it hit one of the boulders when it was coming down, it was not coming back up again. So they knew everything had worked when they regained signal afterwards, and it was reporting that everything went okay. The asteroid is actually Ryugu, and it's about 1 kilometer, or about 2/3 of a mile across. One of the things they've discovered so far, and this is not from any of the samples they've collected, but from all the other instruments they're reading from it, is that it has a lot of indications that there was water on the asteroid. So what it looks like is it was possibly a comet that had all of its water burned away from being this close to the sun. Because it is in an orbit very similar to Earth's orbit, the sun had boiled away all the water that had been on the asteroid. So one time it might have been a comet, but it doesn't have the water anymore to be the comet portion of that. Any questions about that so far?
No, it's interesting. So it was successful then,
Yes.
even though they didn't find a flat surface. They were able.
They were able to find a flat enough surface that when it came down, because the actual probe itself is about the size of a refrigerator, with the solar panels that come out from the sides of it. Mm-hmm. And when it comes down, you're trying to bring a refrigerator down in the middle of a city street.
So do they pull the panels in?
No.
They didn't pull the panels in.
No, it's all out. So that's what made the maneuvering even more tricky.
Okay.
So that's why they were hoping to find a flat surface. So they found the flatter surface, but it was still rocky and boulder strewn.
Smash.
Yeah.
Bang, 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 bang.
Yeah. Second story I'm going to talk about, Elon Musk is coming out with his design for a large spaceship. And it's got some very interesting features that haven't been seen in spacecraft before. The spacecraft is designed to either carry 100 tons or 100 people to Mars. And one of the challenges of this spacecraft is that it's got to enter Martian atmosphere, take off, and come back and land in Earth's atmosphere. The way we do that here right now is either you use these ablative heat shields, and what ablative means is as it's getting heated, the way it bleeds off some of the heat is pieces of it melt away or pieces of it get torn away.
Disintegrate, yeah.
Right. And that's part of the way the ablative heat shields work. The space shuttle uses silicon tiles. Those silicon tiles...
They're permanent.
Right. Well, as permanent as they could be. On this. They were glued on, right?
Yeah.
And many of them did fall off over time. But what they're trying to do is come up with something that's lighter and will allow them to enter enter Martian atmosphere and enter Earth's atmosphere. What they've come up with is they're going to have fuel going through the steel hull of the ship, and there are micro holes in the steel hull. And what's going to happen is the fuel is going to bleed through the holes in the hull and act as a layer of insulation against the hull. So as the ship is going through the atmosphere and as it's heating up from the pressure of the atmosphere, it's going to be bleeding out fuel through these holes, and the fuel's going to be evaporating, and that's going to act as its insulation.
The heat isn't going to ignite the fuel.
That's, correct.
That is my...
Wouldn't vaporize the whole ship.
Yeah.
Well, again, this is the idea being that the fuels could be cold, and there's two parts to fuel for most fuels. There's an oxidizer element, and there's a fuel element. When you got the big tank, when you got the big rocket engines, there's one that's a fuel tank, and there's the other tank that's the oxidizer tank. You need both of those for the fuel to ignite. There are some fuels that rockets use that are much, much more volatile, but without the oxidizer, fuel won't work. So the idea being that since the fuel is already cold, as it's going
and by cold, it's like sub-zero temperature.
Oh, well, yeah, you're talking about cryogenic, liquid nitrogen, liquid helium, but it's going to be very cold. And so that's going to be one layer of the insulation. And as it bleeds through that layer, just like how we sweat, just like how our sweat bleeds heat off of our bodies, the spaceship is going to sweat. They're also using, which a lot of people were surprised about, they're planning on using an all-steel construction for this rocket. And the reason why people are surprised is because a lot of companies have been trying to go to composites because composites are very light and very strong. But what these guys here at SpaceX, Elon Musk company, figured out is that, this stuff is strong, but in certain conditions, like you've got super cold temperatures on one side, super hot temperatures on the other side, steel is actually stronger under those conditions. Plus, steel is so much easier and cheaper to work with, and that's going to reduce the cost of the rocket. Because working with different types of polymer materials, that stuff gets very, very expensive to work with.
I don't know. I'm still skeptical about that.
I don't know if I want to go on that budget spaceship or not.
I don't know. I wouldn't call it budget. It is Elon Musk that's doing it.
I'm just kidding. But
they're the ones that are able to make the rockets land back onto the landing platform. So I'm going to say that, it's still a lot of experimental stuff. It all works in the wind tunnels and in the simulations. They still need to test it by tossing the rocket back into our own atmosphere and seeing how that works.
We need a volunteer.
Well, that's
it won't be manned. It won't be manned when they test
of course not.
No.
The first couple will not be manned to test that out, but then they're going to put people in.
Okay. All
right.
Interesting concept.
It is.
Really.
Anything more to add?
No, I think that's enough for today.
Okay. If you have any questions about these two science stories or anything else science related, feel free to call Alex right now. Lines are open at 203-837-9924.